Alrighty then, time for some fun ones. Oh no. Like, let's take a look at number 5. This is actually not too bad. But the problem is I can't factor this one. So how do we solve it? You guessed it, quadratic formula. So if I use my quadratic formula, I still want to graph this. I got to find the roots. Basically, I got to find the roots. Those are what we call the critical numbers, the CNs. So if I can't factor it, I must use quadratic formula. In this case, because it's a square, so I get negative b plus or minus the square root of b squared minus 4a, which is 1, c, which is 3. Now, if you noticed, over 2. If you notice, we're going to get an imaginary here. So we get x equals negative 3 plus or minus. This is actually becomes I times the square root of 3 over 2. Now notice, the critical numbers are imaginary. And what does that mean for us in terms of the graph? If I try to draw it, here is my x-axis. It will never cross the x-axis. So I have to ask myself a couple questions. What does this look like? Well, that we go back to our type. We know it's even positive, so it has to open up. This must open up. So where is it going to go? If here's my x-axis, if I put it below, my parabola will eventually cross the x-axis. Even if you put it down here like this, it'll go up still. So the only place for this to be is above the x-axis. And there's my parabola. Not exactly pretty, but we know it has to be above the x-axis. So we know that the parabola is always above the x-axis. So how does that help me answer my question? Well, I want it to be greater than or equal to 0, which means it has to be above. So where is it above the x-axis? Everywhere. So the answer, negative infinity to infinity. All right. Now, number 6, I want you to go and try number 6. Now, you have to use quadratic formula, but it will cross the x-axis this time. Try that one. We'll go over that one in class tomorrow. All right, number 7. Okay, easy breezy. It's a cubic, but we can factor out an x squared. X squared, this becomes in 3x minus 9 greater than 0. So I want to get the type. Of course, the type is pretty easy here. It's odd positive. We know what those look like. We also need now to get the roots. Well, to get the roots, we have to factor it, and that's what we just did. We factored it. This is going to give me 0, m2, and this one's going to give me x equals 3. So, and I want to find out where is this graph above the x-axis, so greater than 0. So we want it to be above the x-axis. So if I sketch it out, we have 0, it's m2, and we have at 3. And it's odd positive, so it starts down, ends up. So when I graph it, remember at 0 it's going to bounce down, and at 3 it continues to go up. So where's the one place this is above the x-axis? After 3. 3 to infinity. Soft bracket because we cannot include it right there. It's just greater than, soft bracket. Okay, that's the one thing you want to remember. All right. Now, for number 8, we have to make a slight change to our equation because this one does not work out as well as Mr. Warnow was eventually hoping. So let's change it to something that does work out nice. X cubed minus x squared plus 4x minus 4 less than or equal to 0. Now this will also help you a little bit maybe for number 6. We'll see. So if I want to try this one right here, unfortunately I just can't factor something out. So the type, again, very easy to get. It's odd positive. So we know what it looks like. But to get the roots, we're going to get 3 of them. But to get the roots this time, we just can't factor it. We actually have to use our rational root theorem. And so we have to use our P over Q. Well, P is 4. That's going to give me 1, 2, and 4 for P. Q is 1, so we get 1. So my possibilities, plus or minus 1, plus or minus 2, plus or minus 4. Now, if we find 1, we're set, we're good. So if I do a quick Descartes Law of Sine, just switch my negatives, my odd powers, I get all negatives. So none of my negatives are going to work anyway. So don't have to worry about those, so just the positives. Start off easy, check 1, see if it works. 1, negative 1, 4, negative 4. I have a good feeling about this. 1, 1, 0, 0, 4, 4, 0. Oh, look at that, it works. So I get a root, x equals 1, and I have to have 3 of them. Okay, so if I check my other ones, use my reduced polynomial, x squared plus 4 equal to 0. I can't solve that. Very good. These are going to be imaginary. Okay, which means if I were to even try to graph them, I couldn't. This becomes x equals plus or minus 2i. So where do we graph? So if I try graphing my polynomial, it only has the one root at 1. Because it's odd positive, negative to positive, that's what it's going to look like. But be careful, this time I want less than or equal to 0, so I want it below or equal to 0. And I can include it this time. So where is my graph below or equal to 0? At less than 1. So the answer is going to be from negative infinity to 1. We can include 1, so we make that a hard bracket. All right. I would also like you to try number 9 at home. Now, we'll tell you this, be careful with number 9. A couple things, I'll get this started for you. 1, we do have to make this should be a plus 5 and a minus 3. Now, the only thing I'm going to suggest to you, we have to get it equal to 0. And that becomes plus 8 less than or equal to 0. And you guys can go ahead and finish up on this one, okay? And we'll talk about this one tomorrow. Thank you.